to start with a little bit of a Mentimeter. And for that, I need to actually go out of the presentation. And you can go here to this, sorry. You can go here to this QR code. I hope you still see it. Or logging into your Mentimeter. And then I need to start here. And somehow, I hope you start seeing, I see some response popping up. We want to ask you, how familiar are you with data analysis? I know, like from some of the cases, we have people that's very familiar and others maybe a little bit. I see somewhat familiar is for now, a little, but it's having yeah, that's good. And there's no worries. This workshop is going to be for all, from the ones that are stars on analyzing data to the ones that are just a little bit familiar. And we hope you learn in this workshop. Again, then we have also, yeah, I see here. What tools do you use to analyze your data? And here you can tell us, do you use Excel files, do you use R, do you use some packages, Python, QGIS, Stata, R, so Excel. Net logo, that's new for me. So it's also coming. ChatGPT, that's actually becoming more and more nowadays, right? Like to use also the help of artificial intelligence to use our data. I was actually just doing that a few minutes ago before this, asking. It really helps you to program. Yeah, Atlas, very nice. Yeah, so I see we have here a group of different tools, and we hope after this meeting you can also add some more to your to your portfolio of tools to make sense out of the data we are collecting. Sorry, I'm going in and out of presentations, so bear with me. Okay, well, I'll try to master all these click buttons. So setting up a little bit the scene of what we will do today, and as my colleague Hester likes to say also, like getting the expectations right. So a short overview of what we will do today is we will be bringing data to date. We will have presentations on how to bring the data together and what tools we can use for that to kind of increase interoperability in between data sets. Also different tools on validating the data. That we know how important it is to have data sets that are trustable, and validation is part of that, increasing the trust in our data, not only for us, but also when we want to use the data for presenting to policymakers or to others. And also analyzing the data, making sense of the data, getting graphs, understanding, getting averages. So, and that here we will also show you different of the tools that we have been working in the project, and you will have also time to talk with the people that has been developing them or are more familiar with them. So like R, Python notebooks, also web tools, and also we will have also David talking about wearables and personal exposure. That is another type of sensors that we are using in the project, and some of you showed interest. Also, we will be talking about how to present the data, and also very important, sharing with peers, because we are not going to solve all the problems here, and having forums that connect you with other people analyzing data is actually very important in the work we do. So the aim of the workshop, setting expectations, like one workshop cannot cover it all. But we start here by opening some doors to collaboration so that you get to know who is behind the tools that we are developing, and also who is in other cases that might be facing similar challenge as the ones you do. We want to show you the tools that we develop or that we enhance in the project and that we believe can help you to make your work easier. And also we invite you to use them, to explore them, to adapt, to improve. They are all open source, so you can go into them and modify them and apply them. And just as importantly, we invite you also to share your own tools, and also your knowledge. As you know, we are developing in CitiObs this knowledge platform that we are now working on the first version, where we aim to collect all the toolkits that we are preparing, also the tools and the programs and codes that we are developing are also available under GitHub, and also forums, linked to forums where you can talk with other of your peers. So as I said, and I will repeat this several times during today, all our codes and toolkits are available on GitHub, and they are open, so you can do requests and also get your codes or your knowledge here. Alert, not all is finished, not all is in place, not even all our codes are working, but you can reach to us and to the community. So keeping up this working together. And with that, I think we can give it a start. And we have Miriam from NILU that will present one of the main tools of the project, Virtual Air. And Miriam, with this, I'll give you the voice.
Can you hear me?
Yes, perfect.
Okay. So I will present the tool that we are calling the Virtual Air. So I think that all of you have been working in project and also in this project where we collect a lot of data from different data sources. And what we typically see is that what you probably have experienced yourself is that we have a lot of data sets. People are collecting data, they have their own platform, they have their own APIs maybe that we can connect to, or we can download data from somewhere. But we don't actually know what's out there, how where they are, how we can connect, or we know where they are, the data are, but we can connect to them in different ways. And what we tried to solve with this tool called the Virtual Air is kind of try to connect all of these different data platforms together. So even though the data lives on different platforms, we kind of want to have one access door where you can just open the door and get all the data that you want. So kind of the vision of the Virtual Air was to try to connect, to have one interface, one place where you ask for the data. So the Virtual Air acts like a proxy or a facade API where you do the requests for data, but you don't care where the data actually are. You just want to get hold of as much data as you can, but also to know where they originally are from. So we connect to different observatories and try to make a better understanding of the data, regardless of what kind of platforms and how they were collected in the first place. So the solution we came up with was the Virtual Air. So it's virtual. So it acts as a proxy API, which actually support the Sensor Things API, because we needed to kind of have one common kind of language or dialect to talk. So we are using the Sensor Things API standards. And then all the other platforms that use this kind of standards can register, and they are then automatically available. The data is automatically available through the Virtual Air. Even though we are connected to different platforms, you can always see where the origin of the data is. So it's kind of two different APIs provided by the virtual air, one for registering your observatory and one for getting all the data. Why we try to do that is try to connect all the different data platforms to make it easier and to have faster access to all the data, regardless of where they are. And we hope that this will kind of build a more trust in citizen science data, and also to that we can share knowledge about different geographical locations from one place. So one interface and many insights is kind of the sentence we want to highlight. So that was a quick pitch.
Yes, sorry. Yeah, that was a good pitch. And but then they will have the opportunity to talk more with you, Miriam, and learn how to put upload their data into virtual air and how this works. And then we have our next speaker. That's Vasilis, also from NILU, that will talk on the data validation and data analysis.
So yes, I'm Vasilis. We will discuss about Valer. Valer is a continuation of virtual air, I can say. So the main problem, the main challenge for us was that we are collecting data through different sensors, and also we have a lot of sensor networks. You can see in this figure that the two most popular sensor network in Europe, the sensor community and Perpler. But again, in sensor community, we are collecting data through different sensors. So this so as the availability to develop a tool for this tool to be sensor agnostic, and also to provide some quality control process to put trust to our data. Next slide, please. Okay, so this is the overall the flow chart of the Valer. We have the raw data that we are taking the data from virtual air, and then we're applying a suite of functions to quality control our data. And also we have another suite of functions that we can correct the data, and then we can do again the quality control to have quality control corrected sensor data. So we have two different processing levels, 0 and correct, and 5 quality checks per processing level. The output of this process is that each measurement receives a total quality flag, other good and high, based on the individual quality flags we are having from the individual tests. Next. So this is the structure of Valer. So Valer, we can call it filter now. Filter, it is the framework for putting this trust to our data and to do this quality control and correction. And the structure of the R package, we have one function that it is a connector to virtual air. It transforms the data from JSON to WR format, and in this format we can use OpenAir R package to visualize the results. And then we have the quality control with 6 individual functions, and then the correction. And also we are providing 2 automatic routines. It is for users that they don't want to know anything about the individual functions, so there are 2 built-in functions that they can use and quality control their data. This tool offers flexibility for users to adjust the quality control and correction functions for specific use cases and parameters of interest. We created this filter R package looking at static sensors for PM2.5, but now we have 2 different variants. We will not discuss it in this workshop, for noise and also for mobile sensors. So, thank you.
Thank you, Vasilis. If someone is like me that doesn't know anything about programming, they can also go to your room and learn how to run these automatic routines, and get all their data also validated without even knowing much of our language. Thank you. And then we have, I don't have the presentation here, Jose. Jose will also present the data analysis using Python notebooks.
Hello, everyone. Nuria, yes, is in the next. If you go, you
sorry.
will find like three. Yeah, like these three slides is going to be very quickly. Hello, everyone. In this case, we are working with a different language. To R is Python. So we are working in data recipes for the local stakeholders based on Python scripts. And the idea is to make easy to access the data coming from the APIs like virtual error, sensor things APIs, and other databases. So with these scripts, the first steps is to access the data and make it easy to explore, visualize, and start making sense of the data. So these data recipes, scripts, the main goal is to make the environmental data more understandable and actionable for anyone, and make that exploration, visual exploration of the data, to make it easy with it, because sometimes we have complex data formats or more complex technical tools, or even the lack of time to do it, or expertise, but more of the time is the time, I suppose. So we are working on these recipes, so to be out of the box and just running it and start seeing the data coming from a sensor. So we are making this collection of pre-built scripts. You can see in this screenshot the R text base for the instructions to what the notebook does, an explanation, an overview. Then is divided step by step. Like you need to run, okay, let's see what is about the first step, retrieve the data in this case, in this example. So what is going to happen? What are the inputs that the notebook will ask you? Like, for example, the URL to virtual error or similar, or the sensor ID and the observer property, like normally, And then the user, the communities can follow the instructions and in other cells to run the code. For example, results in the next slide is this typical way to start seeing the sensor data, visualize it, to make daily average, to compare between different days, to compare in weekends or other days, to start finding these patterns, So at the end, the step-by-step guides have three main components: is the code itself, the Python code, but these text-based explanations, and then the results as a visualizations, With some with these three components together, we start making sense of the data, and we are working on performing simple analysis or even calculating their quality index.
They can join you in the workshop to learn more,
Yes.
and to deep into those analyses with you. Thank you.
Thank you.
And then we go also from notebooks and R and Python to web tools. And we have Wouter from RIBM from Netherlands.
Thank you. Thanks for being here. I was asked to tell you something about or to showcase the web tool that we have been developing within the RIVM, which is the Analyze Together tool. And why did we develop this? We actually wanted to help or to support citizen scientists to analyze and to download their own sensor data in a way that they can just load their data within the tool, and then we enable them to combine the their sensor data with reference data. It's the reference data of the National Air Quality Monitoring Network, and combine it with meteorological data from the National Weather Institute. And we did this all in close collaboration, I would almost say, with those citizens, because they were able to give like input for the tool, and then we did another round of improvements. However, it's never finished, so the work in process is all publicly available on GitHub. So this is one of the important, I think, features of the tool, is that the R code is all publicly available, and we have a detailed manual in Dutch, unfortunately. So I will skip that, but we can move on to the next slide, because there's actually the overview of the tool. So if you would go to the web page on the bottom left here, you end up on a web page where you can, as I said, select your data and then try to visualize the data, make time series or pollution plots, because we make use of the open-air software mostly. And behind the web page, there is a catching database, which is making use of the API we have available within the RVM. And that way you can produce like time series displayed over here in the slides. So in the breakout room, I would like to see how the tool is responding, but if you can reproduce graphs like this, or if you have any questions on the data analysis, I'm happy to be there. So I think this is the last slide, right? Oh yeah. I think all has been said. So this is a teaser of what you can expect. Look into your data and then try to find weird spots, or you see high peaks, and that way we try to support the citizen scientists to analyze their own data, I would say. Yeah.
Thank you. Yeah, so this is another way, right, like of analyzing your data, like already through web tools that are established, and then it's a little bit of a clicking. And then, of course, if you want to go more in depth, then you have also the notebooks, right, like where you need to programming a little bit. And so also together with Walter in the room will be David, that will be also spending a little bit on wearables and personal exposure. And I'm not sure if...
Hello everyone. So the idea here is to talk about wearables. As you know, it's a different kind of sensing technology, and it opens a new range of opportunities and constraints at the same time, because wearables are mobile. In some cases, they will measure air quality indoor, outdoor, in different kinds of places. So comes along many interpretation issues. So how am I going to process the data? So beyond the tools to do the analysis, it opens a big range of new questions we should ask ourselves when we are processing the data. So I have a few examples ready for you to see what can be done with that type of data. Of course, on the other hand, I'm very curious to see what you guys expect from those tools and what you have may already done with that kind of data. And yeah, that's what we will see.
Thank you, David. And then I will talk a little bit on behalf of EOC, the Fab Lab team in Barcelona, because Oscar could not be today here, on data visualization. And here is a little bit of advertisement on going beyond plots and graphs, because where we will obtain today will be a lot of time series graphs, but also when we want to go beyond that, in CitiObs, we have created a toolkit that's called like Citizen-Led Action Toolkit to help you work with creatives and do this collaboration together with them, so you can have other ways of presenting your data that goes beyond plots, and there can be like paintings in the street, also lights that illuminate a building, showing connecting to your sensor and showing the PM 2.5 levels, as you can see here. Also, screens that can be mounted on the squares, and not showing numbers, but showing sentences, getting to activate the people in this case to maybe lower their voices so that the neighbors could sleep, right? So different ways, and we will have a workshop in CitiObs with devoted to the citizen-led action toolkit, and I invite you also to join that one and learn more there on novel ways of visualizing your data. And yes, this is a little bit like my cry of help, but that's I think it's for later on. So now what I will need is actually a little bit of help, as we are going to pass to the second part, and that will leave you a little bit of minutes of rest. But before you are resting, I need to know, wait a second, so many organizing and clicking, and I'm incapable of doing two things at the same time. Yeah, I see I didn't have, like, now we are going to, sorry. Now we are going to divide you in rooms, in breakout rooms, okay? We have like some minutes and we will do some breakout rooms. And we have different breakout rooms that you can choose from. So we have a breakout room, and I will write them here in the chat. So we have like the breakout room 1 that will be talking about virtual air and how to analyze how to upload your data into virtual air, and also how to analyze the data, then validate it using R, and visualizing the data using OpenR. That will be room 1. On room 2, we have also Jose that will be explaining more about the Python notebooks. And on room 3, we will have also Walter talking on web tools, and together with David.